Up to this point, we've worked with the law of sines in dealing with only angle side situations. All right. And today what we're going to do is we're going to deal with side angle situations. Now, we call this a law of sines the ambiguous case because when you've got a side angle, you could have any of three possibilities. You could have 0 solutions for your triangle, 1 solution, or 2 solutions, depending on what you're given and the relationship of the things you have. So let's take a look at our first example. In this first example, we've got triangle ABC, and we've got an obtuse angle A given to us. So I'm just going to roughly say this is 145 degrees up here. Call this A, which means little a is down here. And then let's just go B, 10 here, and small a of 2 there. All right, now, so right now I'm given a angle followed by a side and another side, or 2 sides and an angle. So in this case, we look at the picture directly and say, hey, wait a minute, we've got an issue here. Because from geometry, we know that the greatest side is always opposite the greatest angle. And in this case, the side of 2 is opposite a 145 degree angle, and then I have a side of 10. Well, this is not a possibility. There should be no solution for this triangle because it doesn't fit the rules of geometry. Now, let's say you didn't know that. Let's say we just grinded through a law of sines calculation. So we would say the sine of B over the value of side B, which is 10, is equal to the sine of A, which is 145, all over 2. And we're going to work that out. So we say the sine of B is equal to 10 sine 145 over 2. So B then is equal to the inverse sine of 10 sine 145 over 2. And when we do this and try to find B, we get an error. And that tells us that there is no solution. So sometimes when we're given a side, another side, and an angle, okay, we find there's no solution right off the bat. And it just pops out for us. And law of sines will always tell us that. Now, there are some rules that we've got to look at. So given a side angle, all right, if the side opposite that given angle is greater than the other side, there's only going to be one solution. If the side opposite the given angle is less than the other given side, there's going to be either 0 or 2 solutions. Those are your only options. Now we just had, if you look at it, 2 sides and a given angle. And the side opposite the given angle, so in this case, it's this side here, was less than the other side given, other side being 10, we either had 0 or 2 solutions. Now, in doing law of sines, we ended up with getting an error, and so there was our 0 solutions. We'll work through a couple more examples and use these laws to talk about the problem. So again, we're given 2 sides, 1, 2, and an angle. And in this case, the side opposite the given angle, which would be the side of 12, is bigger than the other side. By the law we just looked at, that tells us there should be one solution. And I'll explain why there's only one later in the lesson. So we go through and try to solve this triangle now. In doing so, we're going to take and first of all find the side or the angle opposite 7. So we're going to be looking for angle C. So we're going to take the sine of C over 7 is equal to the sine of 126 over 12. Grinding out all the math, I have 7 sine 126 over 12 is equal to the sine of c. C is going to be the inverse sine of this quantity of 7 sine 126 over 12. And our calculator should give us an answer for this now. And that answer for side or angle C is going to be 28.15 degrees. So now we know this is 28.15. So therefore, we can find angle A by subtracting the two angles we already have from 180. And this leaves us with about 25.85 degrees. So we only have one more thing to find, and that would be the side A. So we use law of sines and say A over the sine of 25.85 degrees is equal to, and again I'm going to use the given information in this, 12 over the sine of 126. So A, after multiplying to the other side and then plugging into the calculator, will equal 6.46. And I've solved the triangle. Let's move to the next example. So in this example, we have a situation where I'm given, once again, two sides and an angle. And you'll notice in this case that the side opposite the given angle, so this is the side of 50, is less than the other side of 65. So in this case, we're going to get 0 or two solutions. And we don't have really any choice. It's either going to be 0 or it's going to be 2. So I start grinding through the problem. And the first thing I'll calculate is angle A. So I want to say the sine of angle A over 65 is equal to the sine of 35 over 50. I can find A by multiplying by 65 and then taking the inverse sine. So sine inverse of 65 times sine 35 over 50 will give us the value of A. Pop that into your calculator, and we end up with A equaling approximately 48.21 degrees. So we'll put this right here. This leaves us with a value of C after subtracting from 180 of 96.79. Now, here's a situation. Since we know the side opposite the given angle was shorter than the other side, I only have two possibilities. One, that I have no solutions, which isn't the case, or that I have two solutions. So since I have one solution, I've got to have two. And I'm going to show you how to find the second equation now. So you'll notice I've got a compass here. And if I take this compass and put one point on C and the pencil drawing part on A, you'll notice that it measures a length of 50. Now, we know what a compass does is it draws arcs of circles. So what I'm going to do is I'm going to actually draw the arc of a circle starting at point A and see where it ends up landing. So here we go. I drag this around And you'll notice there's my arc, my arc, my arc, my arc, and eventually it comes back and actually hits the circle again, or the triangle again. Now, you'll also notice that if I were to take and connect this point to the vertex in which I originally started, I create a new triangle. Okay, that triangle looks something like this. And in this new triangle, I have a 35-degree angle, I have a side of 65, and I have, since this arc is the arc of a circle, I have a side of 50 here. So this is 50. Now you'll notice I now created on the left here an isosceles triangle where this side is 50 as well. And we know that in isosceles triangles that the base angles of those triangles are equal. So this angle down here is 48.21 degrees. What I want to do is I want to find all the dimensions of this triangle. This is my second solution. Clearly, this triangle that I've drawn in black over here is different than the original triangle drawn. It's a lot smaller in perspective, and the angles are going to be different. So notice, if I know that this angle here is 48.21, then I can find the angle on the other side of it because it's supplementary. If I subtract from 180, I will get that value. And after going through the calculation, we get this angle being 131.79 degrees. So right here, this angle is 131.79. Now I have two angles of this new triangle. I can find a third by subtracting from 180. This gives me a value of 13.21 degrees. And that angle is this interior angle here. So really, here's my B, here's my C, here's my A. And the only thing I have left to find in this new solution is my new side C. So C in this case is found by taking the law of sines again, C over sine of my new angle C, which is 13.21, equals, I'm going to use my original measurements again, 50, which is the side of B, over the sine of the angle opposite 50, which was 35 degrees. So C ends up equaling whatever 50 sine 13.21 over sine of 35 is equivalent to. And that value is going to roughly 19.92. And so what we've done is we've had an initial condition where I had the side opposite the given angle was less than the other side, and I found two solutions. Solution 1 being here, solution 2 being here. So there are two possible triangles that can be formed from those initial given conditions. Take a look at that again if you need to, but here are the questions I'm going to have you answer today, and we will probably discuss this again more tomorrow.